In this video, we'll be doing a quick 10 problem review on lessons 4.4 through 4.6, all about triangle congruence, where we covered CPCTC, SSS, SAS, ASA, and AAS. All right, so indicate the answer choice that best completes the statement. Find the missing reason in the flow proof. So we've got this triangle picture. We are told that RS is congruent to TS, and they're marked here. I always have to mark up all over pictures when they give them to me. And V is the midpoint of RT. So in our flow proof, they start off giving our given their own boxes, right? And we always write the statement in the box and the reason below it. Statement in the box, reason below it. Okay, to prove our two triangles congruent, that's what we have to do. We have to have at least 3 congruency statements. And right now we only have 1. So how can we use the given? This is one of our statements, so it's going to cut right to our triangle congruence. How can we use the given to come up with another congruency statement? V is the midpoint of RT. If this is in the exact center of RT, what does that tell us? That RV is congruent to VT. And so they wrote this box here. They drew an arrow. Based on this, we can then say that RV is congruent to VT. Why? That's what we're missing. Because V is the midpoint, right? Definition of midpoint. So this is B, definition of midpoint. Once we say that we have these 2 congruency statements, we also can say, unrelated to any of that, that VS is congruent to itself, right? Or SV, or however you want to name this. It's congruent to itself, whether it's used in the top triangle or the bottom. So based on this picture, all 3 sides of one triangle are congruent to all 3 sides of the second triangle. So the 2 triangles are congruent based off the SSS, the side shortcut rule. Okay, number 2, determine which postulate can be used to prove the triangles are congruent. If it's not possible to prove, write not possible. All right, so here it gave us 2 sides are congruent, and it gave us this angle in here, right? So what are our choices? We have CPCTC, SSS, SAS, ASA, or AAS, right? CPCTC is when we have to prove all 6 parts, all 3 angles and all 3 sides of both triangles are congruent. Well, we don't need that here. It's not even a choice, so that one's out. Okay, could I prove all 3 sides of both triangles are congruent? Absolutely. It tells me these 2 are congruent and these 2 are, and this third side is shared. So it's the same exact size, whether it's used up here or down here. So I could absolutely say SSS. So if it doesn't include SSS, we're going to mark it out because that's the main one, okay? So what's the other one I can use? Side, angle, side, or angle, angle, side, right? Well, it gives me 2 sides, so I'm thinking this guy, but let's just look at it. Side, angle, side. If I know this side is congruent to this side, and I know this is a 90-degree angle, that tells me this has to be a 90-degree angle, because they make up a linear pair, they add up to 180. And I know for a fact both triangles have this side congruent, because it's the same side, right? So I have side, angle, side. So SAS. To have angle, angle, side, I'd have to know that 2 angles are congruent. These 2 are not marked congruent. These 2 are not marked congruent. So it has to be side, angle, side. So we have this guy and this guy. Done, easy peasy. Number 3, sports. A pennant for a sports team at Lincoln High School is in the shape of an isosceles triangle. If the measure of the vertex is 18, find the measure of each base angle. So isosceles has 2 legs that are congruent. In this picture, we can pretty easily know that these are the 2 congruent legs. We're not going to think this guy is congruent to one of the long sides. So if these are the 2 congruent legs, that means this other guy here is our base, right? So the angles here and here are our base angles, which means this is my vertex. It has to be 18 degrees. So if this guy's 18, the 2 of these are the same size, and all 3 add up to 180, right? I can say 180 minus 18 equals 162. So these 2 angles have to add up to 162. Since they're the same size, I'm just going to divide that by 2. and I get 81 degrees. Each angle has to be 81 degrees. So A. Number 4, determine whether the triangles, given the coordinates, whether the triangles are congruent given the coordinates of the vertices, explain, right? Well, given the coordinates of the vertices, we're not going to be able to figure out angle measure unless it's a perfect rectangle, unless they have 90-degree angles that line up with vertical and horizontal lines. That's the only way we'd know that if that's the case. So we're just going to plot the first few, right? -7, -3, backwards 1, 2, 3, 4, 5, 6, 7, down 1, 2, 3. -4, -1, 1, 2, 3, 4. Yes, I do realize that this is completely not marked. Oh, sorry, you can't see it. That this is not marked congruent. We're just gonna leave it here for now. And then -2, -5, backwards 2, down 1, 2, 3, 4, 5. Okay, so based off those 3, I can go ahead and kind of sketch those out. And then I need to plot the other 3 over 1, 2, down 2, over 1, 2, 3, 4, 5, down 1, 2, 3, 4, and over 0, down 1, 2, 3, 4, 5 here. Okay, so they're gonna look something like this. I'm a terrible drawer. This graph is not completely accurate, so there's no way for me to just look at them and tell, right? They also do not have 90-degree angles that are obvious to me, right? If they were made up of 2 sides were vertical and horizontal, I would know that one angle is 90. In this case, I don't know what the angles are. It doesn't tell me. It only gives me vertices. So the only way I can prove these are congruent is if their sides are all congruent, if all 3 sides are. So to find the length of the 3 sides, I have to use the distance formula, right? I can also narrow down my choices. I know that it can't be side, angle, side, because I can't figure out angles here. And I know it can't be angle, side, angle. And then corresponding sides are not congruent. So I don't know about A or D. So I'm going to go ahead and find out the length of each side. So first length I'm going to find is DE. DE, -7, -4, -7 minus -4, -3 minus -1. -7 plus 4 is -3, -3 squared is 9, 4 square root of 13. That was, I'll put D, E, shouldn't have wrote D. Okay, next one is EF. -4 minus -2 squared plus -1 minus -5 squared. -2 squared is 4. -1 plus 5 is 4 squared is 16. So that's square root of 20. And then the last side, I did DE and EF, so DF would be my last side. -7 plus minus -2. Y minus Y. -3 minus -5. -7 plus 2 is -5. Squared is 25. 2 squared is 4, square root of 29. Okay, so my 3, oh, sorry, you couldn't see me that math. I did the distance formula just for one of my triangles using these 3 vertices, right? This is my first triangle, DEF. So I found the length of side DE, side EF, and side DF here. And without simplifying it anymore, because I can't take, none of these are perfect squares, I'm just gonna leave them under the radical. And all I'm gonna do is compare them to the other triangle. If they're the same, I know the triangles are the same. If they're not, I know the triangles are not the same. Do it a different color, sorry. Okay, so first side I wanna find is PQ. It doesn't matter if I'm finding the corresponding sides. I just need to find one side that's the same as one of these, right? PQ, if I'm looking up here, I get 2 minus 5 squared plus -2 minus -4 squared. Do the math. 2 minus 5 is -3. -3 squared is 9. 2 squared is 4. Square root of 13. Okay, so far, we have 2 sides that match up. Let's do the next side. We have QR. So here I'm going to do 5 minus 0. squared plus -4 minus -5 squared. And when I simplify that, 5 squared is 25. -4 plus 5 is 1. 26. Okay, so this doesn't match up with the other two. The 13s match, but the 20 and the 26 don't match. The 29 and the 26 don't match. So these are not congruent triangles. The only thing this whole situation had going for it is if all three sides here were congruent to all three sides here. And we already found that at least one pair of sides doesn't match up, right? And that's enough to know this side right here doesn't match up to either one of these. So we know that all three sides can't be congruent. So our answer is going to be D for number 4. I know that's a lot of tedious work, right? Sorry. Number 5. All right, find the missing statement from the paragraph proof. Remember our thought process, whether it's a 2-column proof, a flow proof, or a paragraph proof, is all the same. We're coming up with logical steps, logical statements, and for each statement, we gotta have a mathematical reason why we did that, right? So here, given that angles D and F are congruent, and they're marked congruent here and here, and GE bisects DEF. This guy bisects this angle, so it cuts it into 2 congruent half angles, right? We have to prove that DG and FG are congruent. We have to prove that this guy, this whole side here, is congruent to this whole side here, right? So in order to do that, we're going to have to first prove that these two triangles are congruent to each other. And then anything after that, we know the corresponding parts are congruent because corresponding parts of congruent triangles are congruent. So since it's given that GE bisects angle DEF, we know that these two smaller angles, DEG and what's the other one? FEG, this guy and this guy, by definition of an angle bisector, are congruent. It is given that angles D and F are congruent by the reflexive property blank, right? Well, what's the only thing up here that is the reflexive property when we say something is congruent to itself? Well, both triangles here share side GE, right? Whether it's used in the top triangle or the bottom triangle, this side is the same measure because it's the same segment, right? So reflexive property, by the reflexive property, we can say GE is congruent to itself. So this guy, B. And then we have enough to say that the two triangles are congruent by angle, angle, side, because we know this angle is congruent, this angle is congruent, and the side not connecting them is congruent, this one or this one, right? And once we say our two triangles are congruent, therefore, DG is congruent to FG by CPCTC. Always. After you prove triangles are congruent, anything that comes after that is because of CPCTC. All right, number 6, determine which postulate can be used to prove the triangles are congruent. If it's not possible, right, not possible. Here, these two sides are congruent to these two sides. They both share this third side. So we know it's the same size, whether it's in this guy or this guy. So the triangles are congruent by SSS. And then we have a bow tie shape here. Do we have enough information here to say these are congruent? Well, the only thing I know for a fact in these two triangles is that this guy is congruent to this guy because they're vertical angles. And then it tells me this side is congruent to this side, but it doesn't say anything's parallel, doesn't say anything else is congruent. So I only have 2 congruency statements here, and I have to have at least 3 to prove triangles are congruent. So this one's not possible. 7 is D. Last page. Number 8. Now we've got this figure here, and we're going to answer these 2 questions on the same drawing. We have this triangle right here on the bottom. We're going to focus on real quick. This guy, and the measure of angle HMG is this angle right here. Okay, so in order to find this angle, we have to kind of use things we know to add up all these angles, and we know they add up to a straight line, which is 180 degrees. Okay, so it tells us this, it's hard to kind of see. I know you guys have it there in front of you, you can anyways. This little angle right here is 50 degrees, right? We're missing this skinny little angle here and this angle up here. Well, this one up here is easy because it's an equilateral triangle. We already found out earlier when we had this picture in a problem that this is 60 degrees. So this is 60. What we don't know is this guy, right? So to find that out real quick, we can just kind of use what we do know. All the angles in this top angle are 60, including this guy on this side. These two angles make up a linear pair, which means they add up to 180. So this angle has to be 120 degrees. And if this is 120 and this guy is 50, they add up to 70, which means this one has to be 10 degrees, right? And these make up a linear pair. So if this is 10, this angle here has to be 170. And for this angle, this long skinny angle here, this is an isosceles because this leg is marked congruent to this leg, right? They're marked with these two little hash guys. So if the vertex is 170, that only leaves 10 degrees left over for these bottom two skinny angles to add up to. And if it's isosceles, these are our base angles and they're the same. So this guy right here has to be 5 degrees. And this little missing angle that we needed up here is 5 degrees, right? So we've got a 60-degree angle plus a 50 plus a 5 plus whatever HMG is. And they all add up to a straight line, which is 180. So 60 plus 50 plus 5 plus the measure of HMG add up to 180. 60 and 50 and 5 is 115. If I subtract 115 from both sides of my equation here, I end up with 65 degrees. So this angle right here has to be 65 degrees, B. And then for number 9, the measure of GHM. GHM is this angle, okay? Again, this is isosceles. If this base angle is 65, that means this angle has to be 65. How do I know they're both the same, they're base angles? Because this side here is marked congruent to this side. So these are my two legs, which means this is my base, and my base angles are touching my base. Okay, so if these are both 65, now I'm looking for this angle. 65 and 65 is 130. All three have to add up to 180. So 180, 80 minus 130 equals 50 degrees. B. Sorry, I didn't realize you couldn't see that. And then lastly, last problem of the whole review here, number 10, we have this picture and it says if STV is congruent to SVT. STV is this little angle down here, is congruent to SVT, this little angle down here. Then name two congruent segments. Well, if that's the case, that means that this is my base and the sides across from these two base angles have to be congruent because the base angles are congruent. So this is an isosceles triangle and this side is congruent to this side. So SV has to be congruent to ST, which is D. All right, let me know if you have any questions and good luck with your review assignment.